Alright, let's take a look at this problem. How many odd perfect squares are between 10 and 10,000? Now, I don't know about you, but that looks like kind of a hard problem. You could start just by trying to list them all out and counting them, but that's going to take a while. You could start with, well, let's see, 4 squared is 16, but that's not odd, so we'd have to start with 25 and then go to 49 and so on and list them all out. But that's going to take a while to get all the way up to 10,000. So I want to show you a trick for doing these types of problems and counting numbers without actually listing them out and counting them. So it's sort of like counting without counting, which is kind of a neat trick. So let's take a look at an easier problem. Now you're gonna laugh at me because you're gonna say, now this is way too easy, right? How many numbers are in this list? 1, 2, 3, ... 41, 42. Now I should maybe first of all mention that this ... here just means and so on. Okay, so we're repeating the pattern. So mathematicians like to be efficient. They're always looking for efficient ways to do things. They don't like to do a lot of just number crunching and a lot of work. They want to use their minds and figure out things logically. So so mathematicians have certain conventions that they use to save labor, and this is one of them. Instead of listing out all of the numbers, they'll just list enough to give you an idea of the pattern, and then put ... which just means and so on. So you can imagine what the next number is going to be. It's going to be 4, and then there's going to be 5 and 6 and so on. So so the 1, 2, 3 just gives you enough to establish the pattern. The ... just means the pattern continues, and you go on to 41, and the last number is 42. So now, like I said, you're going to laugh at me because this seems like too easy of a problem. How many numbers are in this? How many numbers are in this list? Well, 42, right? That's pretty easy. So, but let's take a look at it. What if we were to do something like let's add 4 to all the numbers in this list. So if we say plus 4, put a little colon, then we would have a list that looks like 5, 6, 7, ... 45 and 46. Now, if I were to ask you how many numbers are in this list, well, we know how many numbers are in this list, and all we did was add 5 to every number, so it didn't change the number of numbers. So this list also has 42 numbers, right? So if this list had 42, then this list has to have 42. Let's do something else. Let's try, what if we multiply all these numbers times 3? Okay, then we'd have 15, we'd have 18, we'd have 21, and let's see, this is 135, and this is 138, right? So again, if I asked you, how many numbers are in this list? Well, we really haven't changed the number of numbers in the list. All we've done is multiply every number by 3. Whoops, I forgot the ... here. ... All right. We haven't changed the number of numbers, so there's still 42 numbers in this list. So here is the trick for doing these kinds of problems. The secret is to find a series of operations that translate the list that you're trying to count into a list of counting numbers that look like 1, 2, 3, 4, 5. Because if the list starts with 1 and increments by 1 each time, then obviously the last number in the list is just going to be the number of numbers. So if we can take a list, if we start with a list that looks like this, then we can easily convert it. In this case, we could divide by 3, and we'd end up with this list. And if we were to subtract 4, we'd end up with this list, right? And then it would be easy to count. Alright, so that's the trick. And I want to work a few examples here and to give you an idea, and then I have posted a worksheet as well for you to practice this technique. Alright? So, alright, here's a fairly easy one. How many numbers are in this list? 7, 8, 9, 35, or 34, 35. Now you can see that they're incrementing by 1 each time. So if we just shift this list by subtracting 6, then we'll get 1, 2, 3, and so on, all the way up to 35 minus 6, which is 29, right? So the answer is that there are 29 numbers in this list. Okay? Here's another one. Now, this one looks a little trickier because we're starting with negative, but it doesn't matter. It doesn't matter. They're incrementing, they're increasing by 1 each time, so we're adding 1 each time. And so in order to make the first number 1, let's add 13 to it. Okay? And then we get 1, 2, 3, all the way up to, what does this become? 88, right? Or sorry, what am I saying? Sorry. Okay, 72 plus 13 is 85. Okay. So the answer is 85. Okay? So, now, let's look at a little trickier problem. I have to watch my time here because I have to be able to post this on YouTube and I don't want to run out of time. But okay, here's another one. How many 3-digit numbers are multiples of 7? Okay, so basically what that's saying is we're looking at numbers from 100 to 999. Those are all 3-digit numbers. So let's see if we can convert this into a how many numbers are in this list sort of thing. So let's take a look at, okay, what's the first 3-digit number that is a multiple of 7? So let's say, okay, well, we know that if we take 10 times 7, we get 70, right? And that's not quite enough. We want to add 30 more to it. So if we were to add at least 30 more, so if we were to add 35, which is a multiple of 7, we get 105, right? So that has to be a multiple of 7 as well. Okay? So 105 is the first number, right? Because if I'd only added 28, that would have only been 98, which wouldn't be a 3-digit number. Okay? Now I think I'm going to finish this in another video at part 2. And so look for part 2 and I'll finish this problem.